A high school baseball player throws a ball straight up into the air for his math class. The math class was able to determine that the relationship between the height of the ball and the time since it was thrown could be modeled by the function f of x equals negative 9x squared plus 20x plus 6, where x represents the time in seconds since the ball was thrown, and f represents the height in feet of the ball above the ground. What do the x and y axis represent? Reread the problem. So if we look back at that last sentence, it says x represents the time. So this is our time. And f represents the height. Therefore, the y-axis will be our height. And here is x, y. So again, x-axis represents the time the ball is in the air, and the y-axis represents the height of the ball at a given time. At what height was the ball initially thrown? What do you think the number represents in the context of the problem? So initial tells us y-intercept. And the y-intercept is here, and you'll notice that the point is given. So to me, 6 represents, well, first of all, that's the y-intercept, right? 6 feet. And that represents to me that that was the height at which the ball was thrown, and that could be the player throwing the ball from the player's height, or you could think of it the ball being released from the player's hand, right? I would accept either one of those because those make sense in the context of the word problem. So the height of the player or the height of the ball when the player releases the ball from their hand. Does the initial height of the ball and the function have any numbers in common? Well, yeah, right? We see 6, and then we see 6 over here, which is our C value. And we learned in the investigation part 1 that C is our height when the quadratic function's in standard form. So the number they have in common is 6, and 6, which is C, is a constant. And it's also the initial value, or the y-intercept. What number is the leading coefficient of the function? How do you think this relates to the shape? So we said the leading coefficient in the last slide was the number in front of the highest variable, right? And we learned that in Unit 1 as well. Well, the number in front of the highest variable here, or I'm sorry, the highest exponent attached to the variable is 2, right? X squared. So the leading coefficient is negative 9 because negative 9 is attached to the variable with the biggest exponent. So negative 9 is our leading coefficient, and negative 9, we said in the last problem with the basketball, remember when A, which is negative 9, is negative, then it faced downwards, and as soon as we made A positive, it went upwards. So the negative 9 is related to the shape of the parabola because the parabola is concave down. So negative 9 and concave down are the major things you should have said in your response. What does the maximum point mean in the context of the problem? Well, we know the maximum or the vertex, right? Those are both the same thing. Maximum is the same as vertex. Represents the ball at its highest point. So that's at 1.111. So after about 1 second, the ball reaches its maximum height of about 17 feet.